Hey folks, Darren with Fervent Astronomy. Today we're looking at this, the Sony 20-70 f4G lens for Sony E-mount. Why would we be looking at this lens for astrophotography? Good question. It's because no lens that I own doesn't get tested. And that's about as truthful as I can be. This probably isn't going to be your number one choice for astrophotography. It's an f4 zoom lens. That being said, it is a lens that you might have on you when you have no other choice, and maybe this can help you make a decision if you can use it in a pinch. The G lenses as of late have been getting really well acquitted physically, especially build quality wise with features, and this lens is no exception. We've got, in addition to this extending zoom, a physical aperture ring which has an iris lock right here, so you can lock things in the A setting where you can control the aperture via the camera, or you can lock it in the physical range here where you can take advantage of these sweet clicks. Can you hear that? We can also declick the aperture if you're going to use it for video work, and yeah, that is nice to have for sure. This particular lens has two custom buttons, and it's not to say that they can be used for different things, but you can use either one depending on if you're holding it portrait or landscape. I mean, this is not a G Master lens. It's nice to see. And right below that one custom button here is the autofocus manual focus switch. The electronically coupled focus ring is really loose. I'm not a fan, but it is what it is. And overall, build quality is quite good. There's a tiny rubber gasket around the back bayonet here, and I guess that's better than no gasket. The hood is a pedal-shaped hood. It's all plastic, one piece, I believe, and it lacks that rubberized front or the button that some of the G Masters have. Below our 72mm front cap is a 72mm filter thread and not quite a 72mm front element, which is fine. I mean, it's actually a fairly large front element, all things considered. Maybe vignetting won't be too bad, but overall, this is a really nice walk-around lens, and it might be the case, like if you're someone like me, where you just walk around until it's very dark, and then you might want to take some night shots. So we'll take a little look at this in Lightroom and see if that's even worth trying. Hey folks, and welcome to Lightroom, where we continue a series of I have it, therefore I will test it lens reviews. In this case, we're testing the Sony FE 20-70mm f4G lens, a very slow zoom lens. What could go wrong? Obviously, this isn't going to be your typical choice for astrophotography, but maybe this will be of use to somebody, so we're going to take a look. Here I have a bunch of samples, and they are taken at different focal lengths at f4 with this lens. Going through the aperture range here is sort of a foregone conclusion. You don't really want to stop down to f4, never mind past there. So everything here is shot at f4 with the Sony a7R Mark V, tracked 60-second exposures, tracked with the Fornax Mounts LighTrack II portable star tracker. If you want to learn more about that, Fervent Astronomy is Fornax's exclusive North American distributor, so head over to ferventastronomy.com and you can check it out there. While you're there, actually, if you follow the link in the description, you'll be brought to a page where you'll get a series of links, including an explainer on ISO invariance. And that will explain why I am taking these photos at ISO 320, which is this camera's second base ISO, because the A7R V here is what we call an ISO invariant camera. It's also got a dual gain sensor. All that means that it actually only has two analog amplification stages, or as I like to call it, quote unquote, real ISO values, 100 and 320. Everything north of 320, the camera is just taking the shot from 320 and it's amplifying it digitally. What that does is it will look better on the back of the camera, but you're not gaining anything. In fact, you might be losing something. So between, let's say, ISO 320 and ISO 6400, I can boost the lower ISO image up to the exact same level as the higher ISO image. I can get the same noise, the same shadow recoverability, all that good stuff. The only thing is at 6400 or anywhere above 320, in the case of this specific camera, what might happen is I might blow out the highlights and they might get locked in at a higher value than they otherwise would, which might lose me some information. So let's say if I was taking a picture of a galaxy or some other bright thing, I might actually blow the highlights out and not be able to recover them at 6400 when I could have shot at 320, got the exact same noise performance, the exact same information, all things considered, if the exposure and aperture were the same. That's the caveat. All that being the same, I might be able to retain some highlight detail by shooting at 320. So it really is a no-brainer. While you're there and you're looking at the LighTrack II and you're reading the article about ISO invariance, you can actually download these samples and by all means, pixel peep, peruse them, spend hours gazing longingly at the corners and whatever aberrations you might find there. But please respect my copyright and the effort I put into getting these, which involved buying the lens. This is a lens that I own, so please use these in good faith. Thank you so much. Let's jump right in here. First, we're going to go to the 20mm focal length here. This is Ursa Major. I don't know if you can tell, and I've already had to boost the exposure in all these to make them even this visible. If we look in the upper left-hand corner at the navigator, we see that there is some vignetting. It makes it a little easier to see up here. We also see that there's a bright halo around the center, which is a little darker. This being a zoom lens, it's not uncommon to have some, let's say, more unconventional light fall off. So this is what's going on here. It's almost like a little bit of reverse vignetting in a way. If we scroll through 24mm, it's still kind of the same story. Here we are at 28. I think it's largely rectifying. There's a little bit of vignetting here at 35. It's okay. 50, 70, all things said and done, it is pretty even at the longer focal length there. And even here at 50mm, there's a bit of a brighter area in the center, but nothing that won't be correctable. Now let's pop into the center here. And overall, level of contrast looks okay. There's nothing really to compare it to, but f4 is not really that fast, obviously, so we wouldn't expect a big loss of contrast. We've got a little bit of chromatic aberration, maybe some purple fringing here that's going to be what it's going to be, but overall not too bad. This star here might exhibit a little bit of spherical aberration, which is to say there's a little bit of bloat, a little bit of loss of contrast around this star. Although this is almost certainly an aspherical lens, you'll always have a little bit of a risk of some spherical aberration, and that might be what's happening there, but it's not a big deal even if it is. Let's just scroll through some of the samples here and we'll see what else we can find. As we zoom in to 24mm, things look about the same. 28, about the same. 35, 50, 70. At 70, it looks like we might be getting a little coma here. And coma, or chromatic aberration, is thus named because it has stars start to take on a little shape that is reminiscent of a comet, or a comet tail. So you get a star, then you get one edge that's fuzzy, and it starts to maybe turn into a bit of a wedge shape. And it looks like that could be happening here. There's two types of coma, internal and external. Internal will point towards the center of the frame, the tails. External will point the tails towards the edge of the frame. Here, the tails, if those are indeed coma, are pointed this way, which is towards the edge, one would think. So if we kind of follow it through, starting to see that maybe things aren't very flat field here at 70mm. Definitely looks like external coma, but that is a little bit odd because that means I can't find the true center of the lens. And the true center surely isn't up here. All right, well, we do have a little bit of that chromatic aberration, some spherical distortion here as well. I would say this lens is probably weak here at 70, which isn't the worst thing because you would think it would be a little bit more useful wider. We can just go back in time here. 50mm. Yeah, still a little loss of contrast and some fringing. 35, same deal. 28, 24, not too bad. And 20, back to where we started. One thing that we might want to take a look at, of course, is the corners. So let's go take a look. Here's a bright star. This is a bright star exhibiting astigmatism. We already talked about coma, which in the 70mm focal length would look like this. Pretty sure this is some coma happening, although it's very light. We're now looking at astigmatism, which is commonly found in the corners of the lens. Coma is not something that you would necessarily find in the corner of the lens more than anything else. Coma is often attributed in name when actually astigmatism is what's happening. And that's one of the reasons I'm doing these reviews, because very few people kind of know the difference, I guess, but also look at things in detail. So here there's two types of astigmatism, and this is tangential astigmatism, which is to say that it lies along radii that go from the edges to the center, and is stretching the stars out along those radii. Sagittal astigmatism tends to intersect at a 90-degree angle to this, and in aggregate looks like it's ringing the frame. In this case, I actually can't find any good examples of sagittal astigmatism. Maybe this little blue fringy bloating on this particular star might be some sagittal, but in this particular lens, or at least at this focal length on the zoom, I don't see any. Let's scroll through here. Here we are at 20 millimeters, 24 millimeters. Actually, here we got a little more sagittal coming out to play here. This little effect here is going to be the sagittal, but it's not that big of a deal, all things considered. When we're over here at 28 millimeters, I don't see as much sagittal astigmatism, but I do see what looks like defocused stars. And if we jump to the center again where the stars are in focus, this is giving us a clear example of field curvature. Field curvature is when your, let's say, center is in focus, but maybe as you go out towards the edges, you lose focus. This can be pretty extreme or it can be mild. In this case, at this particular part of the zoom range, I'm confident in saying that there's some defocusing happening here in addition to the astigmatism. Is it a big deal one way or the other? I don't really know. I don't suspect. As with the astigmatism or any other aberration, when it becomes a problem for me is when it makes the stars around the edges bloat up or look warped or otherwise give an uneven effect across the frame. If it's minor, it's not going to be really noticeable. People are going to focus on your subject. If it's pretty extreme, well, they might take a little bit more of a peek and it might break their interest in the actual subject. So for that reason, when this stuff tends to happen, that's how I assess how bad it is. Not here zoomed in at 400%, but rather at a normal viewing size and distance. So it is here. There is a bit of field curvature, a little loss of focus in the corner, and we move on. Now at 35 millimeters, that field curvature seems to have rectified. There's a bit of a warping of the star shapes here. Here at 50 millimeters, mostly dominated by astigmatism, not that big a deal though. And 70, here the astigmatism is a little bit more defined, definitely more classic astigmatism. Here we've got our tangential and our sagittal astigmatism. But when zoomed out, it doesn't really affect the experience of the photo super, super critically. There is that mild coma in here, however. Taken into account, man, this lens does have a pretty decent zoom range though, eh? Let's pop into develop module, and we can see I already had the corrections enabled. My bad. It is worth noting that some lenses will automatically apply profile corrections, and this is because the lens is designed with those corrections in mind. Whereas the old school way of doing things would be to essentially optimize your optical formula as much as possible. Now, lens manufacturers, since we have a lot of extra resolution, what they will do is they'll actually use a electronic lens element, as they call it, and they'll design the lens around what they're able to achieve optically, given that they can fix some distortion and whatnot digitally after. That can be a win or lose depending on the particular type of situation, but it can keep costs down, it can make some things possible that weren't possible before, etc., etc. In that vein, it can actually apply automatically when you pop it into Lightroom. So some of the characteristics with the vignetting that we looked at are actually going to be null and void at this point. So I'm just going to scroll through here really quick. This is 20 millimeters, 24, 28, 35, 50, and 70. And you can keep an eye. I'm going to go backwards now, and you can see how things develop there. But definitely here at 20 mil, the vignetting does appear to be worse than it appeared originally. And we're losing that dark patch in the middle and the donut there. So that applied, well, I certainly didn't apply it. So keep in mind that it might apply automatically. And if that's not what you want to happen, you might want to come and disable them from jump. At any rate, let's zoom in here. Profile corrections for chromatic aberration. Nope. So we defringe it with the dropper. That works good. Now we can flip this on and off. So the profile corrections are indeed fixing a lot of the vignetting, but not all of it. And they are leading to this darker spot in the middle. That's where you might want to come in here and adjust things up a little bit to try and even them out and get maybe a little bit more of a true representation of a evenly exposed frame, but that's up to you. You might also have to resort to masking if things are really out of whack. As we enable this profile correction, we'll see at the long end here, the middle of the frame tends to jump out at the viewer and the edges push away. So this profile correction puts a geometric transformation on the frame here, which pushes the center away from the viewer, pulls the edges towards the viewer a bit. If we scale down, we can see how that's being accomplished. And of course, this means that we're actually losing some of our frame. So if you watch the stars at the top and bottom edges, the left and right edges and the corners, you'll see here is what we have. And indeed, in the corner here, this is essentially black. Like, that's really not that great. And when we enable the profile corrections, we do lose a bit of field of view corner to corner. Not really up here at the top and bottom, but definitely in the corners and associated near edge, we will lose some field of view. So whether or not our 20 is still a 20 millimeter focal length field of view, we're probably losing a bit, but all in all, it's not such a bad thing. Here we are, 24. We'll just flick those on and off, largely the same. Barrel distortion getting flattened out, losing a little bit in the corners. 28, same deal, losing a little bit in the corners, correcting some barrel distortion. 35, we actually have pin cushion distortion now that's getting pulled out towards us. And that means we're retaining the corners. They're not really shifting, but we are losing some on the top and bottom. You'll watch how it kind of bulges out, and a little bit on the sides, left and right here as well, but not too bad, all things considered. This is what that transformation looks like. Kind of bulges out of the frame, but the corners stay put. 50, same thing, pin cushion, bulging a little bit to correct it. And 70, same deal. This one actually seems a little bit more aggressive, however. That being said, you do retain corner to corner field of view. You are losing some of the edges, however. All right, well, this lens is probably just in a pinch or second line choice for Astro. These are tracked, mind you, so keep that in mind. So we'll reset things here and show you how dark these images really are. Right, 20 millimeters at f4, even if a minute exposure, it's quite dark. It might make an okay star trail lens, but you will need to track it otherwise. All right, well, let's pop out of Lightroom and wrap it up. Well, what'd you think? No surprises, really. This is not going to be my ride or die. It's not going to be the first lens I reach for when the Aurora come out or anything like that. In a pinch, any lens is better than no lens. So I hope you have found this review interesting, or at least a little bit informative. And yeah, hopefully we will see you in the next one. Darren with Fervent Astronomy. Take care.